Hello guys, welcome to Solving Solutions, your number one channel where you get solutions to all your solving problems. It's nice having you in class again today. How have you been? We are going to look at something on software today. We are going to show you how to carry out cut and fill analysis, right? Good. In software, or let's say generally when you're carrying out some tasks that have to do with volume of earth materials or definitely earth materials. There are times you have to cut some parts, there are times you have to fill up some parts, and you don't just cut and you don't just fill. There's actually a quantity that you have to cut, a quantity you have to fill, and there will be left a residual, right? Good. So on today's video, we are going to show you how you can use software to determine those values and then maybe give you a better perspective of the quantity you are going to work with. So thanks for coming to class. If you're coming to the channel for the first time, you can encourage us by subscribing, and if you are a returning viewer, thanks for always checking up on us. So this is the official, should we call it official? Yeah, this is the official documentary from Software Help. The cut and fill volume section of the grid volume report displays the positive volume, that's the cut, and the negative volume, that's the fill. Now the cut portion is the volume between the upper and lower surface when the upper surface is above the lower surface. There are two surfaces in maybe when you want to determine volume. We are going to show you that. Now one surface most times is the base surface, then the other surface is the top surface. Now when we say base surface, it's like for this particular what do I call it, cut and fill, it might be the level, or let's say the grid, or the elevation you want to get to, right? Good. That can be your base surface. Then the top surface would now be a complete topography of that area. So the idea is that you need to use your base surface as a reference, right? Good. As a reference. So if let's say you are having a range of elevations from let's say 15 to 20, your normal coordinates are there, but your range of elevations are from 15 to 20, and per design you are to work with an elevation of 17. You know that you now have another surface called 17. Then you have a surface that has elevations from 15 to what? From 15 to 20. So what this particular cut and fill analysis does is that, making reference to that 17, it is now going to interpolate those elevations you are going to cut, which is above 17, and those elevations you are going to fill, which is what? Below 17, right? So that's what this particular part of the explanation means. The cut portion is the volume between the upper and lower surface when the upper surface is above the lower surface. However, the fill portion is the volume between the upper and lower surfaces when the upper surface is below the lower surface. And we've told you that your upper surface can be the complete topography, whereas your lower surface can be maybe an elevation you want to use by design, right? Good. So calculating, these are some of the, what I call it, the algorithms, the different formulae that we are used coming up with the values, right? Good. Then the net volume is the difference. It's the difference after you have your cut and your fill, right? Good. So you can see from this figure here, we have a cross section showing the relationship between upper and lower surface and the cut and fill volumes. Now the surface is defined by 75, which means that 75 is the second surface, whereas the other is the other is the first surface. So when you have the elevations below 75, you can see that you're going to fill, and when you have elevations that are above 75, you see that you're going to cut them off, so that you now have a level 75, maybe 75 feet or 75 cm, as the case may be, which you can see the lower surface is defined by C of 75. Are we together? So this is just like an explanation of everything you need to know, or let's not everything anyway. There are still so much you need to know, but this explanation suffices for what we are going to delve into on today's video. So enough of the theories, should we call it theories? Now let's see what we can do with software. So now we have our software here, and we want to bring in a grid data, right? Good. So you come to what grid data. Good. So we are actually using the conventional grading. Let's just use that. We would have used triangulation with linear interpolation, but let's use the conventional grid. So you go to what? You go to browse. Good. So we are actually working on the folder volume on software. We've actually we have our data there. We have the contour data. So we select data and then we say open, right? Good. So the data columns are not well filled. So let's view the data to see. Our B is supposed to be easting, C is supposed to be northern, and then D is supposed to be height, right? So we have what this is supposed to be easting, this northern, and then this height, right? Good. So with this, I think we are good to go. Let's just skip to the end. Good. Now the output grid is here, right? Good. So let's specify a particular output folder for it. Good. So we are actually moving into a folder called cut and fill, right? So let's call it contour data, or let's say cut and fill data, possibly. Let's just call it cut and fill data, right? Or cut and fill grid, because this is the grid already. So let's call it cut and fill grid. Good. So we have this grid saved on a folder called cut and fill. So we just save. That's the output, right? Good. So the new, now the one of the advantages, well, let's one other important way you can use this is by checking this. If you want to load a new map, and the type of map you want to load after you've actually loaded your grid file, right? So if you decide to say contour, which is the default, and you click on finish, it will load the contour map from that grid, right? I haven't saved it, or let's say I haven't created that grid file. We also have our contour map displayed on our screen, right? Good. So now this is one perspective. Okay, let's try to see if we can work on the field. Let's remove that. Good. So this is one perspective of our terrain, right? Of the terrain we are working on. But it will be better we see it in 3D. So we still go back to the folder. We open that our cut and fill grid, and then we are going to see another perspective of our terrain, right? Good. So now this is the 3D perspective of the terrain, and then this is the 2D perspective. Yeah, let's use that. Now these are the two depictions of the same terrain. Are we together? These are the two depictions of the same terrain. Now upon looking at this, we can see that okay, we also need to load the data. Okay, we can actually see the data somewhere around grid data, right? Good. We need to show you the data we are using. Let's still come back to browse. Good. Now what I wanted us to do was for us to be able to view this data. All right, it should be better, because there's actually a spreadsheet function of what do you call it, of software. Good. Now we can see the range of elevations, right? We are having 24, 25, 26, 27, 25, 26, 27. You know, it's actually a very large data set. We have 28, right? Good. If it was on Excel, I think I should have been able to sort it out. We have up to 30 as well, and then keep going. You know, we are trying to see the range of heights we have. So upon seeing this range of heights, so that you know what informed the next surface we are going to have, right, during the cut and fill analysis. Now these are the range of heights we have for this particular terrain, right? So we are having from we have 28, right? So we have from, let's say, 24. I think the lowest should be, the least should be 24. So we have from 24 to about 31 or 32, right? Good. So with this range of height, we want to say that by design, we want our topography to get to 28, which means all of those elevations that are below 28 will be filled up to 28, and all of those elevations that are above 28 will have to be cut to get to 28, right? Good. So the essence of opening up a spreadsheet or data is for you to visualize the range of elevations we have, which will now inform what our next surface, and the surface we are going to use now is what, 28. Please bear that in mind. So let's do that. Good. So we have what are two perspectives here, two representation of the same terrain. So we now come down to what? We come down to grid, and we go to what? We go to volume, right? Good. Now the first surface, definitely you can click on this because we already have two grid files that are on our map window. You can click on this and either select your contour or 3D surface cut and fill, or you click on browse to navigate to the folder it is being saved, right? Good. So we have the cut and fill grid here. Just open. Good. So that's the upper surface. However, instead of choosing another grid file for our lower surface, we say 28, right? Good. Instead of choosing another grid file for our lower surface, we are going to use a constant which will now serve as what? Lower surface, which means that the next surface for this particular volume on this particular grid volume will be what? 28. And we've told you in the beginning why we have what? 28, right? Good. We have by design chosen 28 as the elevation of that particular terrain, and we want to reduce those that are above 28 and fill up, that's cut and fill up those values that are above and below 28 respectively, right? Good. Then our scale factor is 1 because all our units are the same, right? Good. We don't have a polygon, so upon setting up all of these on your grid volume window, ensure you pay attention to why we chose 28, right? Good. So just click on finish. All right, now we have what grid volume computation, and then we have our report. Now from our report, it is obvious that okay, I wouldn't want it to be that over the screen. Good. From our report, we can see that the minimum Z value for the default data or the first surface is what 24. The maximum is 31, right? And our lower surface is what? Is 28, which means we are going to fill up 24 to 28, and then we are going to cut what? 31 to what? To 28, right? Good. So we are now going to come down to the volume section and look at what? The cut and fill volume. So this means that we are going to cut this amount of volume from the highest grid value down to, from the highest Z value rather, on the first surface down to 28, and we are going to fill this amount of volume from the two surfaces to get to what? To get to 28, right? Then this is the net volume, that is cut minus fill. Having subtracted both from each other, then you have this as what? As the remnant. Are we together? Good. So this is how you carry out, or this is how you determine what the cut and fill analysis of any terrain. However, that's not the end. We are still going to look at how you can see these in a better perspective, or let's say how we can display this in a better perspective. So let's see how we can change this our color to something different from grayscale. Let's use should we use yellow red? Let's use yellow red, and then we apply, and okay, this shade. Apply, and then we say okay. So let's check this so that it will come up. So this is now yellow red. Let's come down to our 3D surface. Let's change this our 3D surface to yellow red as well. We need color ramp. We need a color ramp that has two colors, because we would want to use those two colors to see how we can represent the what we want to do now. So we are now going to superimpose these two perspectives of the same terrain. Let's see how that goes. Good. So we have something like this, right? We have something like this, and that's not the end. Let's now see what else we are going to do. Let's see our base. Let's show the base. Good. Let's show the base. Then let's now see this in 3D, right? So you click on map and then you go to 3D view. Good. In the 3D view now, you can see what are would I call it the separation surface. Remember, we had one in our illustration here where we had 75 as the separation surface. Let's say the lower surface, right? Good. So you can see we have something like 28. So if you look very closely, you will see that all of those values that are above 28 are reddish, whereas those values that are below 28 are yellowish, right? So you now see that this shows that, let's say from this, you can now see in 3D. Good. You can see this is 29 because it's above 28, right? Good. So from this, you can be able to see that all of those values you have above 28 are going to be cut because they are actually above your lower surface, and then all of those values you have below 28 are going to be filled because what, they are actually below the lower surface. So by the time you cut these volume of materials off and use it to fill these particular or maybe these spaces here, use it to fill these spaces, then you are going to have a uniform, yes, you are now going to have what, a uniform terrain of what, of 28. So this is another way of showing the showing the cut and fill analysis. I think our choice of color wasn't doing justice to that. I don't know if we can still change something to two distinct colors, like two colors that are not so close. Blue and white should do that. Let's see, apply. And then it's still okay. Let's come down to this. Let's see blue and white. All right. Now you can see that the 3D depiction of the terrain is on, and there is one other beautiful tool I just saw which can help us see our second surface and the volume of cut and volume of fill. Now when you click on water, it gives you the surface of water which you can toggle. You can toggle the elevation to different values, right? Good. So for this particular video, I decided to use 28 as the surface of water, right? Or let's say as the water surface. So that 28 will now give us a very good depiction of our second terrain, and then it will help us in a very great extent, which I can see, or which you can also see, the volume of cut and then the volume of fill, right? You can see this is an inverted 26.2, right? Good. Which is below our surface of 28, right? Good. So with this, you can now see that 29 is well above 28, which is what, above the water level, or let's say not the water surface anyway, because it's not actually the water surface, but we are just using that as the just to show the second terrain, right? Good. So the color can be white, the color can be anything else. We decided to use white. You can use red. Let's use red and see. You can decide to use red. You can decide to use any color that can show you that that is where one of the surfaces end. You know, it wasn't on 28, but we chose to use 28. It shows us where one of the surfaces end. So we can now see live, or let's say we can now see in 3D the volume that are above what, the surface of 28, and then the volume that are what, are below the surface of what, of 28, right? Good. So this is how you get what the perspective of this is how you visualize. Let's use the word visualize. This is how you visualize what your surface data. So I believe we have been able to exhaustively we have been able to explain to a very great extent how you can carry out what your cut and fill analysis using software. So these are the different values we've told you. The positive values are the values you cut, the negative values are the values you fill, and then the net value is what the value that is left. And since it is negative, which means it is what it is to be what it is to be filled, right? Good, it's to be filled. And we have a documentary from let's say explanation from software on how this cut and fill volume work. So the link to this particular example or to this particular explanation or documentary will be on the description section of this video, where you can actually read it up, and then you can also see some other useful tips and tricks on how you can use software. So yeah, thanks for coming to class. We hope we've provided solution to this particular surveying, engineering, geological, that's a wide range of application problem, right? Good. So we've been able to solve this problem. So we are going to see you on the subsequent video. Ensure you keep staying safe. You can support the channel, see the channel description or the description section of this particular video to see the links on how you can support the channel. And if we can do anything together, do not hesitate to send us a mail, and we are going to get back to you as soon as possible. So until we see you on our next video, keep staying safe and have a very good time. Bye.